Hi, everyone. So we had a session that was scheduled a little bit too late in the afternoon, and it was so amazing. It talked about really AI's impact on routing. And the discussion, I sat in for the whole session. It was so compelling. I wanted to make sure that we sent it out to everyone. So Ray Mota, many of you will probably know Ray. He kind of runs ACG research. Ray is the moderator for that, and he has this really great panel. There's Mark Burley, who's the CTO of the data center business over at HP. There's JB, who's the director of product line management over at Ciena on the panel. Ali Shakai over at Graphian. Ali is amazing. Like, he is smart as a tack, great confidence, and a wonderful personality. So you really enjoy Ali on this panel. And Neil Anderson, I've known Neil for a really long time when he was back over at Cisco. But Neil is the VP of Cloud AI and Infrastructure Solutions over at WWT. So it's a really great panel. Want to make sure that everyone had an opportunity to see it. Also, Ray is not just kind of a typical analyst. He's also put together a thought leadership piece on segment routing. And so there's a companion white paper with this as well. So enjoy. I know I did when I was there.
First of all, thanks everyone for joining in. If I'm talking too loud, raise your hand. If I'm talking too low, raise your hand. I like an interactive crowd, right? So part of this session, in case you're in the wrong area, this is related to AI, network optimization, predictability and capacity planning, and also some parts on segment routing. So if you're in the wrong place, it's a good time to leave now, right? So good, we want to make sure. So by way of introduction, my name is Ray Mota. I'm the CEO and principal analyst for ACG Research. We focus with a lot of service providers and a lot of large enterprises on doing a lot of research work, but also a lot of architectural roadmap on strategy and implementation, which is probably why they asked me to be here with this area. And I was a former CTO in Wall Street, and I used to think AI existed back then, because I used to, every time my CEO would bring in consultant, I'm like, oh, there's the AI group, all right? So I used to call them artificial consultants there. So by way of introduction, I'll start with Mark Burley, who's CTO, data networking for HPE. And I'll let you guys introduce yourself and what you cover. Then we're fortunate enough to have Jahanse Bakai with Ciena, who's a product line manager. I don't know if your title changed, but if it changed, let me know. And stuff, who's an expert in segment routing and network architecture, but more importantly, the simplification of network. And then we have joining us is Neil Anderson, who's Vice President of Cloud AI and Infrastructure Solution for WWT, who's a good partner of mine. And for those that don't know, they're doing a lot of AI work from a design, implementation, and vision. So it was good to connect with them. And lastly, but not least, an old guy that we go way back there now, Ali Sheikh, who's with Graphian. He's Chief Product Officer. Is that correct? Okay, so I got through that. Okay, so maybe we'll just start real quick, since we're, Mark, if you want to just start with an introduction of yourself, because I read some of your bios. I'm like, I'm not going to go over that part there.
There we go.
Yep.
All right, perfect. So yeah, Mark Burley. I'm the CTO for data center networking at HPE. And, we're really focused at what we can do in the data center from a networking perspective. As you know, we have a majority provider of data center equipment in everything but networking. So I'm there to change it. I did about 15 years at Arista prior and about the same at Cisco. So data center is what I do. And I had the pleasure of working with a lot of these people, including Sony and that MPLS gang at Cisco, and then Jayshree and gang at Arista. So excited to talk to you more about the topic today. So,
my name is Jahanse Bakai. You can call me JB in short. I'm a director of PLM from Ciena, responsible for all the IP transport which run on the boxes, including segment routing, RSPTE, old technology like MPLS-TP, LDP, and I'm here to represent what happened with the AI and the segment routing. Hopefully, we'll share some insight of that. Thank you.
Hey, Neil Anderson. I've been at Worldwide for about 10 years, vice president of our cloud infrastructure and AI team. What that is basically pre-sales architecture for our global customers and making sure that, we can design the networks that they need, as well as cloud and data centers and anything that they need to for their infrastructure.
So I am definitely the youngest. I have the least amount of white hair, I suppose. Ali Sheikh. I run product for Graphient. So we're rewriting protocols for the internet backbone and IP backbones, and with a view to data networks in terms of how AI is going to end up using the data networks of the future. And I would say, I think of all of us, I'm probably the one who can still write code.
I can still write a little,
Oh,
a little
there we go.
Python. I don't know if you call Python code, but a little Python. Well, thanks. So, and I'm glad everyone was able to join. So maybe rules of engagement, right? Is there interruptions are allowed, right? We don't have to be nice. I mean, part of this is to educate the audience on what we know. So if you feel passionate, you want to go back to it, it's okay to interrupt. So I like to make it as interactive as possible. So I kind of broke the discussion into 5 to 6 different areas. The first part is related to the AI models and the data sources, right? And one of the things that I get a lot of questions on is what are the type of models that are proven to be most effective in predicting traffic and things related that are critical for network optimization. And I think, Neil, you've got some areas on that question that you wanted to address in there.
Yeah, we've been experimenting with that and different concepts like, can you do a digital twin of a network? What does that look like? Can you actually use that and the data that you can glean from real world traffic to simulate that and predict outages? It's a really difficult space. You know, it turns out you can use that data for a lot of insights and even real-time traffic steering and real-time adjustment of, you know, which circuits you're using or how you're approaching, forward error correction. There's a lot of things you can do with that data. Super hard though to do predictive is kind of what we have found. So any comments on that, guys?
Yeah, I mean, it really depends on the use case, but when you really look at the analytic side of it, there's a lot of Bayesian and decision tree type algorithms, but I'm seeing a lot of interesting things with K nearest neighbor and studies around how that works better. I really think it depends on what you're wanting to measure. I think the biggest problem that we have, and Neil touched on it, but we didn't really dive in, is the collection of this data. If you think of the speeds that our links are running, it's not good enough to have the gazintas and the gazautas, the go in, go out, the bits and bytes in and out. I have to understand, who's talking to who, what ports they're talking on, and, the duration of their conversations and all those different types of things to really be able to make intelligent decisions. And I think that's one of the biggest challenges that we face when you look at like an AI powered network and you're saying, oh, we're going to have an 800 gig interface. We're going to have a 1.6 terabit interface. How do you ingest all of that telemetry data to make good decisions? And if you look at most of the solutions out there today, they're going to give you sampling rates of, at best case, 1 in 8,000. And you can't make good decisions on 1 in 8,000 packets. So anyway.
And I think that highlights sort of a couple of areas, right? One is going to be, how do you handle this data collection? And we may have to at some point come to some conclusion that for a while we might not be able to. So we're going to need synthetic telemetry to teach the models and say, okay, given these parameters, this is how you deal with it. And so that's going to be a big area in terms of synthetic data generation. In terms of the models, I would say there's a lot of models proliferating. I think RAG is probably the easiest to start with, and it gets the least crazy or makes up stuff or hallucination problems. So you can at least deal with statistical analysis and get some kind of prediction and anomaly. So RAG is pretty good for that. The challenge that I see, I'm not in the terabit or like data center space, so I don't have that problem yet. For me, the bigger problem ends up being the actual training data set, making sure that's clean and so that it can actually be used for something. I mean, I can write software for RAG and that's fine. The model's there and I can inject synthetic data and it'll learn. But is the actual data set good to make decisions on? That's the problem. So how do you convert JSON to English and not lose a lot of value is where I'm seeing the challenges.
I just want to add a couple of things here as well. While looking in the network in the real life deployment, when the things are deployed over the majority of the network, service provider, MNOs, whatnot, the collection of telemetry that talk about it get more and more complicated because the number or mix of protocols you have in the network, type of service that's been deployed, and then you go for the AI, the telemetry is the lifeline. And then when we go and customer talk about collecting telemetry, they have older devices and new devices, so there's no one fit solution all. that can collect all the data, and that one solution work for everything, on top of the scale of the network, plus the bandwidth which we consume. And we know telemetry is such an important thing. So this all create extremely challenging environment that you need to make sure there's a heterogeneous environment with the older technology, like 10 years old devices versus newer devices, protocols, services, which like coming like from later VPN, older technology, to new services, EVPN with active standby configuration, and the network converging all the time. So these are extremely complex scenarios that we presented as well.
This is good.
Yeah,
Oh, wait, go ahead.
just a
Good. I
final
like the
comment.
interruptions. Go, keep
Yeah,
going.
Just
Yeah.
final comment, like, you know, you mentioned RAG, and,
Yeah.
you know, I think you're exactly right, kind of merging your two concepts. You're going to have to have a trained model based on historical data, but it's only as good as what's happening in real time. So how do you handle that volume of data in real that's coming at you in real time? But the same perspective, you know, you have to have a reasonable model. You can't just have an infinite model that's just growing and growing and growing. It's a super hard problem, but I do think that there's hope for learning based on a past historical problem. How did it get remediated, and then making recommendations to either the operator or taking action themselves. I think there's a lot of promise in that technology.
Yeah, no, I think I agree. I mean, I think the RAG is a low-hanging fruit for many people to consider, to go out there and say, my environment. This is an easy way without doing this massive production and doing some refining of the data within your own, whether it's a knock and then lead to network optimization. Now, I did hear a few people mention real time, right? What I see in a lot of cases is when people work on AI models, there's a hypothetical type, you know, what if type scenario. But in many cases, when it gets to network optimization, it's real time, right? For that. What are your points on how do you address and understand the real-time traffic when working with these models? Because in this case is you're kind of flying the plane, right? And you need to fix it and tweak it and optimize it and still keep the plane flying. Any thoughts on that?
Yeah, I mean, I look at it a little bit like the analogy if you look at analogies in security, like you're able to, for IPS, for example, intrusion, you can recognize a certain signature of something that's happening, and then you can take action. I almost think that we need to be training on, okay, the last time I saw this condition, it led to a brownout, and you sort of start to recognize those patterns and then take an action. I'm not sure if that answers your question, but that's my immediate thought for how do you address that?
Okay.
Yeah, I was going to say, typically, if you look at outages, you know, if you look back in your syslogs, it told you about it 3 weeks ago. You just ignored it. I mean, like, seriously. And so when you start looking at traffic and traffic patterns, they can become much more predictive, you know, over time. But, you know, I always question, you know, we talk about AI, and I always ask everybody, you know, are you talking about artificial intelligence? Are you talking about augmented intelligence? Or are you talking about analytics? Because we've been doing analytics forever. Like, I mean,
and automation and automation.
Exactly. So that's really the question. You know, what are you really talking about? You know, are you talking about a network that's truly self-healing and is autonomous, you know, almost sentient in that case? Or are you talking about a network that's using some algorithms to look at historical data and then look at real-time data and then try to make some prediction into the future? And that's really the question I have. I think it's more the latter. Honestly, I think it's more augmented in analytics than it is some sentient being that's running around in your network, to be perfectly honest.
I completely agree. And I think that stems from how we've actually built networks historically, right? They were built by humans for humans, fairly static. Then we built change control and all these other processes around it. And then we built automation. So in a way, we actually need to inject the way we think about AI into the network layer itself as well. So that when we do imagine an AI running inside the network, almost like that logic pushed to the edge at the source of where the data lives, and on demand infer what it needs to do with the traffic flow. I think we're not there yet because it requires re-architecting our networks as well. I think for the next little while, we're going to be in the augmented automation analytical space, learning the use cases, developing as we go. And then the network change will happen within protocol. We'll go L0, 1, 2, 3. Those things will change. And I think that's when we'll see AI in the network. I don't think we're there yet.
So I think we're talking about use case to use case. What we talk about the analytic, it reminded me a scenario when we were talking to a customer, and they come to us and talk about, hey, I can predict something's about to go wrong in the IP network because I start seeing CRC's error. And that was such a unique thing. This is such a simple thing. By just making sure it count a CRC error, a certain pattern, then I can guarantee there's about to something go wrong, fiber goes wrong, or whatnot goes wrong. But in Sienna, since we have layer 0 to layer 1 to everything, and we have the operating system on top of it, or navigators on top of it, so we can actually predict and make sure that we can check what happened on that location. Is it on the windy location? Is it inside? Or some maintenance can be done? This is, I think, where the AI can come and play a part. But indication was CRC error. Like, that's such a simple thing. If we can make sure, count these small stuff and predict what's going to wrong, we can mark that area, something about to go wrong, and see what happened and find remedy to it. So I just want to add a use case that actually happened to us.
Yeah, no, I mean, I think it's good, right? I think the thing is for some people, right? I look at it as a tool, right? Is to say, could this tool help me do things that I do repetitive, right? Where there's automation. Initially, when people ask me about AI, I kind of clarify a few things, saying that don't ask me about AI. Ask me about what challenges or opportunities you're considering first. And I'll let you know whether it's AI or automation or augmented reality. But if you get to the point that you're looking at AI, right, look at it as like electricity. It can be really powerful. It can turn on the lights, move cars, but when done incorrectly, it can do some damage, right? So with that being said, what are some of the challenges that, because you guys are talking to a variety of customers, that you hear when having that discussion of implementing AI, when I use the term like electricity?
So I'm probably going to be the outlier here in a little bit. This is going to sound a little crazy
Good, I like
as well.
it. I like it.
The danger of AI screwing things up, I think it's going to, and I think we want it to, so that it can learn from it really, really fast. And it's going to do that very, very quickly. So it's going to cause potentially like 1,000 outages in one day, and then might not never cause an outage ever again. So I think it's interesting possibilities there. I mean, especially if you see how DeepMind works, how it's worked in chess, in online gaming, in different tournaments. It actually starts creating simulations on its own of how bad things can happen. I think the interesting thing is going to be kind of our own experiences. CRC errors, network, 10 gigabit, 100 gigabit, 400. This knowledge that we have, how do we translate that into something AI can learn? And so the risk is there, and I think the risk is good because it will let us teach the infrastructure, and then it's going to start doing the things that we do for networks.
Yeah, I think you're exactly right. And if we learn from the lessons that we're seeing in Gen AI, right, it's only as good as the data quality that you start with, right? But then you have to tune it, and it has to learn. Somebody has to train that model over and over and over again for it to be really useful and zero in on the accuracy. And I think the same is going to play out in the network space. It's only as good as the analytics data that's being provided to it to learn, but then it's going to take a lot of training and reinforcement learning to, did I get it right? Did I get it wrong? To your point.
Well, Ali, though, you talked about, it's going to make some mistakes, and that's good. You know what? 90% of the outages I've been involved with outside of like a pure hardware failure is an operator. So like AI doesn't scare me at all in doing this, because like it's going to make mistakes, yes, but it's going to be consistent in the mistakes it makes, and it's going to be able to correct. I've worked with many operators who keep doing the same thing over and over and over, and so like it doesn't bother me a bit.
So yeah, again, with layer experience, two stories I'm going to share without the AI. I have a friend who's very into the stocks, and he wake up at 6 a.m. in the morning. He's been for 20 years. He's all the algorithm in his mind. His automation skills in his tools, software driven. He popped the stocks in front of him. Is this time to sell, not to time to sell, or short sell, whatever. But in the end, trigger is on his hand. Every single time when the money is involved, he's not trusting his AI tool or automation tool, because there is something which is beyond the AI, is a feeling of that day, sentimental, which cannot be covered. But still, after 20 years, he's a software engineer. I asked him jokingly, when you're going to trust your tools? And never, because this is my money involved, right? So there's always going to be risk factor involved. There's always need to be control driven, and especially in the environment when you're touching the network, the BGP configuration. If you touch everything, the whole ST is gone. There always been human intervention. There all be a risk involved. even I was talking, the second use case, I was talking to one of my friends from Cisco, he's a service provider in his services center. He says, AI tool is extremely great. It can give me a predictability. It can give me the conflict to correct a certain problem. It can even look over the JIRAs or issues that is already populated. But in the end, the system has rules which prevent AI to do the automation by themselves. It will stop there because it's a customer impacting event. They want customer agreement or some person to overlook these scenarios. So AI is going to be great, but I think, in my opinion, there always be superhuman automation.
Well, but if you think about it, we've had, if you want to, use an incredibly loose term for AI, I mean, Dijkstra's been in our networks for how long? We're not typing in static routes every time things change, right? I mean, so you already have this in your networks, already making decisions for you, and it works right 99.9% of the time. So like it's why, like I said, for me it doesn't scare me. But on the other hand, I'm not a CIO of a Fortune 500 company. That's so like there's a little different
like
risk tolerance.
wireless radio
That's a good
resource
point.
management is another example of AI that's been in the network for a long time. But to your point about I think it's going to be relatively easy to be able to mitigate things like the backhoe problem or the misconfiguration problem. The ones that we're kind of struggling to figure out are that OS had a bug in it, or it missed a routing update, or the CPU went too high on that box and something was missed. Those are incredibly hard to simulate, and I'm not sure how do you predict what's going to happen, and how do you learn from that?
Well, and that's why you have to really be watching at the application layer. You can't be just looking at the network, interface statistics and things like that. You have to have a system that's going to understand how the applications work, learn what normal is, and then start to tell you when you're outside of normal. And I think that's the difference from a network perspective when we talk about network monitoring that we'll see, because traditionally it's just been, what are the counters, what are these, and honestly, none of that matters. I tell everybody, like, the network, and I'm a networking person, the network doesn't matter. Because as far as the application people go, they want it to be transparent. They don't even acknowledge it exists. And that's the way you want it. If you're running a network, you want it not to matter, because that means you're doing a good job. Anyway.
And I think that is going to lead us into how we plan to build some of these things. The way I think about this is, why does config exist in these devices? Config exists because we operate that way. We need it. We have to make sense of it in some shape or form. The AI has no reason to rely on it that way. Configs are going to go away. It's going to get less and less. Things are going to get pushed to the edge. Things are going to get moved closer and closer to the kernel. And you're going to be able to make changes right there. And when I say you, I'm almost personifying the AI at that point in time. It's like things are going to start changing pretty dramatically. We're going to learn, we're going to evolve, but as we develop it, it's going to push that quite differently. Those networks will adapt on the fly, and they will adapt and they will simulate it themselves, how these networks are going to function. I think the best example I will give you guys, if you really want to see how this works, is if you watch DeepMind's expansion on the StarCraft 2 ladder, a video game, competitive real-time strategy. And this artificial intelligence, over the course of one summer, went from being a beginner to a grandmaster champion able to beat everyone. I think the way we think about it is going to change. It's going to learn how we operate networks. It's going to see, I don't need that BGP config. Just like OSPF is an algorithm, BGP is a path vector algorithm. I don't need the config anymore. I can program it. I need to stream the telemetry, get that as quickly as possible. If the GPUs are distributed, I can process the decision as closely as possible. So I'm not backhauling everything. We're at the beginning stages of what AI will do to networks. I honestly think we will be figuring things out as we go. It's still very early, but the kind of transformation that's at our doorstep is nothing like we've seen before. It will be something else.
Yeah, no, I mean, I think I'll just add a few points, because those are some radical suggestions, which I kind of like in a way, though, because it's a big problem we're trying to solve, right? I remember when I was in Wall Street getting yelled at by my CFO, like, you over provisioning the network. I would always provision if it got to 45, 42%, bam, I put in another link. And when he would yell at me, I'm like, well, we both get to keep our jobs, right? But now with this, potentially we could solve that major issue from a cost and efficiency perspective. Now, One of the things that I think is important, right, is that my college professor, every time I used to come up with an idea, here's a tool that can solve this. Here we go, Ray. I'm going to tell you the line I always tell you. A fool with a tool is still a fool, right? So it's so important that when we look at existing environment, if it's a terrible architecture, inefficient traffic flow, throwing AI isn't going to solve it, right? So one of the key things to look at is how do we start taking steps to simplify our environment? So with that being said, I want to just ask a few of the folks is there are some steps being related to segment routing, right? Which is a way to reduce the number of protocols, have a centralized control plane, and create more efficiency, but ideally simplify the network as a way, as a stepping stone to get to that simplification that we have. Now, there's a lot of things related, SRv6, V4, V6, and SRv6 in general. So maybe JB and Ali, whoever wants to talk on it, tell us about your thoughts on presetting and simplifying the network first.
I think this is the key point. I think AI is getting a lot of attention, and I truly believe over a period of time, more and more use cases will be out there, more and more scenarios where you need to make sure the AI works, and more consumer of AI will be there. If we go with by this definition that the AI will expand from the limited community with the limited use case to more broader use case, where we have to have a communication within GPU server within the data center or across multi-domain or on the cloud, and you have to maintain the communication between the GPU cluster with low latency and high bandwidth, or you have a use case where you need to provide a telemetry and a service provider so they can rely on software on top of it or application on top of it, or a customer or a service provider of AI who can sell their AI services to the consumer out there. If there is the case, if this is the way direction we are going, we have to utilize what is already deployed in the network, in the service provider, in the enterprise, in the data center, and making sure what is the requirement of AI, low latency, high bandwidth, lossless connection, and make sure we have the, you can say, the protection available at the service level, at the node level, at the transport level. And on top of it, you have to provide a scenario where you can carve out the low latency network slice for a given services. And also what I'm noticing in the AI, previously when I talk to my consumer or the service provider, how much of your service is actually required an SLA requirement. For example, low latency slice and high bandwidth. It says 5 to 10% out of the whole network. But when you have consumer and when you have AI services going from top to bottom, those numbers will increase. Now more and more services require low latency. So how you get the low latency for a given network where the limitation is there because their best effort going on. So my observation is that going forward, there will be shift in the thinking when you deploy service, rather than finding low latency services or low latency links or higher bandwidth availability, you will be looking for which of my service is hogging most of the network and for what reason. Can I block these services or make the rate limit in such a way that I get more bandwidth out of the network or more latency out of the network? For this way, because I'm the PLM who's responsible for all the transport, so I cannot be biased. Look after RCPT or MPLS-TP or LDP, all the technology, segment routing really stands out. I'm not talking about SR MPLS versus SRv6. Make sure that in people who want to deploy AI network, they are on the bandwagon of segment routing, either on V4 infrastructure using SRMPLS V4 or SRv6, which is based on V6 infrastructure. V6 definitely have benefit because if you want to have a communication between your GPU server or you have a service network function in the network and you want to do service function chaining with the metadata attached, meaning you want to pass an argument to a firewall, hey, I want to treat this traffic according to this is metadata, then SRv6 is the best case scenario. So yes, from my point of view, if you are thinking and you want to move forward and if you want to include existing infrastructure, segment routing is the way to go.
So I think segment routing absolutely has tremendous benefits. I think what we've seen historically, right, segment routing was complicated. It was hard for it to go to, say, a general consumer. Even most enterprises are going to struggle with doing segment routing themselves, even though far superior in so many ways in terms of traffic pathing and deciding how applications get serviced. I think thinking about how we're building, and this is where, I mean, Graphene thinks about it the same way as you described, JB, around segment routing, is the AI will benefit the most from it.
Right.
Because being able to make that decision and operationalize it is so much more effective that way. You're not relying on a human who now has to think about, well, which node SID and adjacency SID am I trying to figure out, and how does this work, and what are the SLAs? Those things are harder for humans. And AI will definitely benefit from that. So I would say we're beginning to see the advent of that kind of infrastructure with AI in mind. I think we're going to see continued evolution in that space. Segment routing is definitely a protocol space we're big fans of as well. But how do you make it consumable? And I know not everyone has CCIEs, but people have networks. People have use cases. It has to be easy to operate. And that's, I think, where we're headed.
Well, and I think, and not to denigrate segment routing, because I think it's a wonderful technology, but you need segment routing from a because I'm going to embed some kind of service, do some kind of service chaining, NFV type of functionality. If you are able to embed those services at the edge, in the network, in line, it radically simplifies the overall design, and that makes things easier to automate. It makes things like AI start to be possible. Because it's going to create a much simpler architecture, and I get out of the redirection. Because one of the big problems that we have, even when we're in a production instance of some kind of AI model, again, is latency. So I want to minimize my number of hops, and that's why I really feel strongly. And you heard Sony Giandani talk about it, DPUs and whatnot, and the embedding of that DPU into the network to allow the stuff that was done as software agents and those kind of things, and it's going to be done online, is truly, going to revolutionize the way we design the networks overall.
Yeah, and my observation is, so far we talk a lot about AI as almost like from a data scientist point of view, right? It's a nice little tidy cluster. I do my work there, and then I've got a model built, and then I can have people leverage that model, right, without a lot of latency. But if you think about, like, fast forward this problem, AI is going to get distributed everywhere, right? And what is the cluster to cluster communication going to look like? What is cluster to edge going to look like? I think it's really early, and I don't know that we have the right answers there. But what I do know is it's going to take network architects to dig into that problem and understand, like, how do I network these things together in a high-speed way that can benefit. How do you basically distribute that AI to the places you're going to need it?
So I just want to add one more point on what Mark was saying about the network becomes simple, and then we can do the automation or network slicing from the edge. I agree with it. I was listening to HP conversation, Andrew and Neha was giving a conversation, and one thing stuck out when they were talking about application-aware network slicing. And I was about to go on stage and help them out, actually, because this is what I'm working right now with the segment routing. Because once you are enterprise or at the edge, you might be asking, hey, give me the low latency slice or higher bandwidth slice. How did it happen? It has to be happen from the network point of view. The network can calculate low latency slice across 10,000 routers or interface or the bandwidth. So it has to go hand to hand. You cannot ignore one to the other, because at the edge, you were just asking a low latency slice or a high bandwidth slice or minimum hop. Even there are some use cases where you want to use affinities, make sure some data remain in Canada or some data remain in US. You want to create a virtual boundary like blue plane, red plane, and find me a low latency size within the blue plane, red plane. This is pure transport level infrastructure. You cannot give a low latency slice to the service or application without you have proper implementation of the network design in the network. So they go hand to hand. You cannot say one is necessary and one is not necessary. They have to complement each other.
And I would say one of the things that I've often talked about and thinking about network was we spent a lot of time as network folks trying to make the network's application aware, because the application people wouldn't listen to us. And we would keep saying, all right, fine, we'll do it. We'll find some logic in, we'll deal with the latency problem. We'll deal with this, that, or the other. We'll create FEC because you won't put FEC in the application layer, all those kinds of things. And so network's been doing that for a long time. And we just keep inheriting that burden. I think especially with things like segment routing with DPUs, what we're actually going to want to start moving to is these are the characteristics of our network and the services we have within the network infrastructure. And you, the application, need an SDK to interact with our network and request the latency slice you want, or the loss slice you want, or the hop count you want. I'm not going to go build application engines in every hop to try and figure out what your application might need.
So Ali, I just want to add what you just said was one of the things that I'm investigating right now, because in segment routing or the transport, there is no awareness of the entity by themselves. If you are deploying firewalls, if you're deploying the gateways, if you're deploying the NFV servers, those are just a prefix or IP address, but there's no characteristic attached to that given entity. The way I see evolution in AI, those entities will announce themselves, hey, I'm a firewall, or I'm a service provider, or I'm this entity. So when you're doing a traffic engineering multiple hops, the system has some way of indicating, oh, this guy is this, and I need to, if there's some requirement on a more adaptive way, I can reroute traffic to this and make sure this happens. So I just want to double click. This is, I think if you want to talk about the evolution of segment routing or transport, this is one of the things which is missing.
This is great because I was assuming that segment routing question would just be like 1 minute. So, but for those that have trouble sleeping, I did write the original use cases for segment routing. So I'll send it to Nick. So for those that are interested, they could be distributed, and it'll guarantee you it's a very technical paper, but it gives you at least the reality check of here's some use cases for you to consider regarding cross-domain, some things regarding mobility and other parts that could be helpful for you to think, because I think this is a key part of setting the stage for the simplification for AI to be more effective. Now, we've got a few minutes left and stuff. Before I ask the final question, anybody got any questions real quick? Don't be shy. You had a question? Nope. Okay. Oh, Nick had a question. Here.
So JP, you were talking about kind of like slicing and various different slices of the network and how an application might kind of want to use those slices. How do you kind of envision, and so there's two parts of this. One, the network has to be configured in such a way to enable that. And the other thing too is that how does the application signal to the infrastructure that it wants that?
So I think this is a very good question, because what happening, as Ali was mentioning, the application was and transport network work in silos. So there's going to be a way to communicate to each other. So there are multiple customers that I'm working currently right now who want this functionality to be enabled, and they come and told me, I have this application, I have this SD-WAN provider or whatnot, but I want a communication between my current what I've selected to your network in such a way it doesn't burden me. So there's always two approaches. Either you have a controller who can control and talk to those applications, understand what the service is all about, tagging them, and they control the transport and make sure when the service is coming from that application, you know what this application is all about and what kind of treatment they need. That's the number one option. Number two option is that by using existing IPv4, IPv6 header, there's some marking that you can use to identify what kind of service you use, cost, type of services in IPv6. And that is, for me, is a more appropriate approach, because when you mark a type of service from the application, you're signaling what kind of service I need. Then you can easily translate or map those type of service header within the network on a given network slice easily without asking in detail that what need to be done. You can go either by the controller way, or you can go by the purely network level information. Both are okay.
But Nick, I thought we already solved that problem years ago with RSVP. No, I'm just kidding. But no, I do think it's going to be incredibly hard for the application to direct that. I think the network has to have some understanding of those applications and what the performance is. So I'm in the network up camp versus the application down camp.
I know it. I always get a lot of people consternated because I'm always like, make the app developer develop some of this stuff. Here's the kit, here's the network, put it in, right?
Well, but you have this in
you know
InfiniBand. I mean, in InfiniBand, we have verbs, and if you look at UEC and what UEC is doing, they're trying to up-level that and create an abstraction layer so each vendor can create their own plugin, and then, to do exactly this in the data center and request the resources and stuff. So I do think you're starting to see, that adaptation of something from InfiniBand into Ethernet that's going to better that data center ecosystem. So, I mean, I do think it's in the works.
No, good question. Well, we've got a few minutes left. Where's this going? Future thinking, and if you could do it within 1 minute, is that possible each? Let's go, Ali.
All right, I will give you the craziest answer of all. I definitely think that the artificial intelligence is going to rework our networks. We're going to have, there's going to be upscaling of our own capabilities, what we focus on as network people and how we design and what we do. because the artificial intelligence is going to start operating the network protocols, the network decision making for the applications and the workloads that we have today.
I think you're right. But I think the road to that is going to be first co-pilots, intelligent co-pilots to help the operator. Then moving into, based on that, it's going to learn what the remediations were and be able to take some automatic options, and then someday get to where you're going.
In my opinion, right now, what I'm hearing about the AI is very loosely termed. Every talk about AI, and everybody has different meaning of it. So over a period of 1, 2, 3, or 4 years, that will get more and more refined. And the more and more refined in such a way that what is use case out of it, but different segment of the market. Every segment of the market, every operator, every user will have own version of AI. And from the company point of view, on the service provider point of view, or customer point of view, the AI has to translate into some significant milestone, either the cost saving, either ease of implementation, either reduction of complexity. Those will get more defined. So this is kind of exciting time. It will, and bottom line is that AI is going to drag everybody into it. You're not going to spare out of it.
Well, we're already here, actually. And if you look at most of your systems, or many systems now, they're all cloud managed. And the cloud manager does a lot of things behind the scenes for you. And as you move forward, these networks are going to, self-architect, self-provision, self-heal, self-operate. And I think even more importantly, when it comes to security, is self-secure. Because, if you've heard any of the talks, there's 30,000 CVEs a year. Just in this time we've been talking, there's probably been 5 new CVEs. The pace of security is outpacing anything that any of us can do. And so it's gotta go down this path. It's the only way, forward. So
That was actually impressive, guys. So just 1 minute left. One thing just to close with, because I get a lot of questions about networking background, and you're still going to need that expertise. I've seen some areas where I've gone in where they've had too much latency in their let's say AI network, and I'm like, well, you're using a bus architecture. If you create a fabric, you could get more. And to me, it was like a basic networking question, but because some of these people come purely from the AI, they know how to optimize networks. So using this tool and stuff. So we always have to make sure that you do need to have a solid foundation to be able to optimize the network. Well, with that being said, I'd like to thank the audience and thank these. It was very interactive. I appreciate you guys. Thank you.